In this lesson, we're going to talk about probability. So what is probability? For example, perhaps you've seen something like this, P of A. What does that mean? This is the probability of event A occurring. To calculate the probability of an event occurring, it's equal to the number of favorable outcomes, or outcomes that lead to event A occurring, divided by the total possible number of outcomes. Now, before we go over some examples that talk about how to calculate probability, we need to talk about something called sample space. So what is sample space? The sample space is basically the sets of all possible outcomes that can occur. So let's say if we toss a fair coin, let's say a quarter. What are the possible outcomes of flipping one coin? There's only two possibilities. You can either get a heads or you can get a tails. So the sample space for this situation is either heads or tails. Now, what if we wanted to flip, let's say, 2 coins? What are the possible outcomes? What's the sample space for flipping 2 coins? To help us get the answer, we're going to create something known as a tree diagram. So when flipping the first coin, we have 2 possibilities, heads or tails. Now, let's say if we get heads during the first flip. During the second flip, we can get another 2 possibilities, heads or tails. Likewise, if we get a tails during the first flip, on the second flip, we can also get heads or tails. So notice that we have 4 possible outcomes. So the sample space is going to be the first outcome, which is heads and then heads. So we can write that as HH. The second outcome is heads and then tails. So that's going to be HT. The third outcome is tails, then heads. And the fourth outcome is going to be tails and then tails. So this would be the sample space of flipping 2 coins. Now, for the sake of practice, what is the sample space of flipping 3 coins? Feel free to pause the video and try that. Construct the tree diagram to help you do so. So on the first try, we can get heads or tails. Now, if we get heads, it can be heads or tails. And if we get tails, it can also be heads or tails. Now, because we're flipping 3 coins, we need to do this one more time. So this could be H or T, and then repeat the process for each one. So here's the first possibility. We can get 3 heads. So I'm going to write that as HHH. The second possibility is getting heads, heads, and then tails. So HHT. The third possibility is heads, tails, heads. So that's HTH. The fourth is heads, tails, tails. So HTT. And then repeating this process, we can see that the next one is going to be THH. And then THT, TTH, and the last one is going to be TTT. So we're flipping 2 coins 3 times. So the number of possible outcomes is 2 raised to the 3rd power, which is 2 times 2 times 2, and so it gives us 8 possible outcomes. So this is the sample space, which represents all the possible outcomes that we can get for flipping 3 coins. Now, the probability of an event occurring is always between 0 and 1. If the probability is 0, this means that this event cannot happen. It will never happen. Now, if the probability is equal to 1, that means that the event will always happen. It also means that it has a 100% chance of occurring. If the probability of an event occurring is, let's say, 0.3, 0.3 times 100 is 30%. So it means that it has a 30% chance of occurring. So if the probability is 0.3, that means out of, let's say, 10 possible tries, we're going to get approximately 3 favorable outcomes, because 3 out of 10 is 0.3. Let's say out of 100 tries, we would get 30 favorable outcomes. So here's an example situation. Let's say that the probability of people who drive a blue car is, let's say if you have a certain population in a city, and if you randomly select a person, the probability of that person driving a blue car, let's say it's 0.20. So that means that there's a 20% chance of selecting a person driving a blue car. So if you were to randomly select 100 people, 20 people would drive a blue car. If you randomly select 1,000 people, approximately 200 will be driving a blue car. And so that's what probability tells you. But now let's work on some problems. If 2 fair coins are flipped, what is the probability of getting at least 1 head? Well, let's begin by writing out the sample space for flipping 2 coins. So it could be heads, 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 tails, tails, heads, or T and T. Now, the event A is getting at least 1 head. So this one has at least 1 H, this one too, and that one as well. So the reduced sample space for A is HH, HT, and TH. So now let's calculate the probability. In order for the event to occur, we have 3 favorable outcomes. The total possible outcomes are 4. There's 4 events in the sample space. So the probability of getting at least 1 heads when flipping 2 fair coins is going to be 3 over 4. 3 divided by 4 is 0.75, which means that there's a 75% chance for this event occurring. Now let's move on to part B. By the way, if you want to try it, feel free to pause the video. If 3 coins are flipped, what is the probability of getting at least 2 tails? So let's begin by writing out the sample space. So let's write what we had before. It could be HHH, HHT, HTH, HTT, THH, and so forth. So those are the 8 possible events or outcomes that can occur in this event. So now let's call the event A. We want to get at least 2 tails. So which of these outcomes contains at least 2 tails? We have 1, 2, 3, 4. So there's 4 potential outcomes that have at least 2 tails. Kind of mixed my words up there. So let's write it out. It could be HTT, THT, TTH, or TTT. So the number of favorable outcomes is 4 out of 8 possible outcomes. So 4 over 8, you could reduce that to 8 is basically 4 times 2. 4 is 4 times 1. So this becomes 1 over 2. 1 divided by 2 is 0.5. So there's a 50% chance of getting at least 2 tails. Now let's move on to part C. If 3 coins are flipped, what is the probability of getting exactly 1 tail? So go ahead and take a minute and work on this example. Pause the video if you want to. So let's circle which outcomes, or let's circle the outcomes that contain exactly 1 tail. So this is one of them, here's the other, this is another one, and that is it. So for event A, or let's call it event C for part C, the 3 favorable outcomes are HHT, HTH, and THH. So the probability is going to be 3 favorable outcomes out of a total of 8 possible outcomes. 3 divided by 8 as a decimal is 0.375. And if we multiply that by 100, that means that there's a 37.5% chance of getting exactly 1 tail if 3 coins are flipped. So those are some simple examples of how you can calculate the probability of an event occurring. Now let's move on to our second problem. A 6-sided die is tossed. What is the probability of getting a 2? Let's begin by listing the sample space. So here's all the possible numbers that we can get. It's basically 1 through 6. Now the probability of getting a 2 is just, there's only 1 2 out of 6 possible outcomes. So we have 1 favorable outcome out of 6, and 1 over 6 as a decimal is basically 0.16 repeating. If we multiply that by 100, but first let's round that to 0.167. So this is approximately 16.7%. So that's the probability of getting a 2 tossing a 6-sided die. Now what about part B? What is the probability of getting a 3 or a 5? So we have 2 favorable outcomes out of 6, so it's going to be 2 over 6, which if you divide both numbers by 2, you can reduce that to 1 over 3. So this is basically 0.3 repeating, so that's a 33.3% chance of getting a 3 or a 5. Now what about part C? What is the probability of getting a number that is at most 4? So let's list out the outcomes that leads us to this particular event. We'll call it event C. So that is at most 4. What does that mean? So that means we can get numbers that is less than or equal to 4. So 1, 2, 3, 4. So the probability of this event occurring, we could say, let's say if x is a variable, so x has to be less than or equal to 4. That means getting a number between 1 and 4, where x is an integer. Or technically, let's say it's a natural number, because integers could be negative. So there's 4 favorable outcomes over 6. 4 is basically 2 times 2. 6 is 2 times 3. So this becomes 2 over 3, which is approximately 0.667. So there's a 66.7% chance of event C occurring. Now, what about D, part D? What is the probability of getting a number that is greater than 3? So let's list out the outcomes that favors event D. So numbers that are greater than 3, that includes 4, 5, and 6, but it doesn't include 3. So the probability of getting a natural number that is not equal to 3 but greater than 3 is going to be, we have 3 favorable outcomes out of 6, 6 is 3 times 2, 3 is 3 times 1, so this becomes 1 over 2, which means we have a 0.5 chance or a 50% chance of event D occurring. So as you can see, it's not difficult to calculate the probability of an event occurring. It's pretty straightforward, but with many examples, you can see what to do. Now, what about the last part, part E? What is the probability of getting a number that is less than or equal to 5? So event E, numbers that is less than or equal to 5, that's everything except 6. So the probability of getting a number or a natural number that is less than or equal to 5 is going to be 5 favorable outcomes out of 6 potential outcomes. So 5 over 6 is 0.833 repeating. So let's put approximately. So there's an 83.3% chance of event E occurring. So that's basically it for this video. Now you know how to calculate the probability of an event occurring. Thanks for watching. Oh, by the way, feel free to check out my playlist, statistics playlist. I do have more videos on probability if you are looking for those topics, such as independent, dependent events, mutually exclusive events, conditional probability, and other stuff like that. Contingency tables and complementary events. So feel free to take a look at that, or you could do a YouTube search and type in organic chemistry tutor, let's say conditional probability, and it will come up. Thanks for watching.